Hello everyone, in this video I explain experiment number 3, resistance in series. How determine the equivalent resistance of 3 resistors connected in series. Let us start. The apparatus that we need: power supply, 4 voltmeters, 1 ammeter, switch, connecting wires, and 3 resistors. We know the resistance of each one. This one 5 ohm, 10 ohms, and this one is 4 ohms. We connect the circuit as shown in the figure. We start to connect the circuit. We're starting from the positive here. So we're starting from the positive. We adjust it. It's better to don't lose any energy. So from the positive of power supply must be switched off from the switch. And from the switch, to the first resistance. We have to put them in order to know which one first, which one second, which one third. So now this one is the first one in order 1, 2, 3. So this is the first resistor, and from the first resistor to the second one, because they are connected in series. So this is the order of connection. We connected this one. Then we connect the third one. Follows each other because they are series connection. Okay. Now they must be in order. We keep space in order. And then from the third one to the ammeter. So this is the ammeter, from the third one to the ammeter. Okay, we connect it from down up to 0.6 ampere. Also, take care for connection must be tight to don't lose any part of energy. And then from ammeter to the power supply. Okay, now we check our connection before we connect any other instruments. Just we check. So we put them in order 1, 2, 3 to be clear. So 1, 2, 3. So switch on. Yeah, the ammeter working. So it's correct. Okay, now switch off. Now we connect 1 voltmeter to the power supply. So this one, because we'll adjust this to 3 volt. Switch off. It's okay. And now we connect each voltmeter with resistor. So this is for the first, this is for the second, this is for the third. So this is the first one. It's 4 ohms. We connect each voltmeter parallel to each resistance. So we connect this one. Take care, don't lose any power. Must be tight. Now we check the first voltmeter. So switch on. Okay, so we switch on this one. Back, so just exchange because the indicator goes back. Yeah, so this is correct. So switch off. So now I can also switch on to check. Yeah, it's working. So for the first resistor, the voltmeter working in a good way. So switch on, switch off, sorry. And now we do the same with the second voltmeter. We check the second voltmeter, switch on, and then we check. No, it is move to the back, so just break it. Okay, yeah, it's working. So switch off the last one. Now we check the last one. Switch on the circuit. Yeah, this is the correct way because it moves in positive direction. Yes. Now all the instruments are working. Ammeter, the 4 voltmeters are working. So switch off, and then we started to take the measurements. First, we adjusted the power supply to 3 volt. So we adjust this to 3 volt before to start. Yeah. Now it's exactly 3 volt. So we complete this one. Now R1 is 4 ohms. So 4 ohms, R1. R2 is 5 ohms. R3 is 10 ohms. So that is R1, R2, R3. Now, V, this is the voltmeter, reads 3 volts. 3 volt. So the voltage, the main voltage from power supply is 3 volt. Now what we do, switch on the circuit and take the reading of V1, V2, V3. So, but take care when you take the measurements, okay? So switch off. Now we read V1. V1, it's 1, 2, 3, 4 dashes, 4.1 dashes, 4.5 dashes. And each one dash in the voltmeter is 0.1. So 0.1 multiplied by 3.2 dashes. So the voltage V1 is 0.32 volt. So this is V1. Switch off. Don't leave the circuit long time to don't overheat. And now switch on and take the reading of the second voltmeter. Now it is exactly 5 dashes. 5 dashes. So 5 dashes multiply 0.1. So it is 0.5 volt. So V2 is 0.5 volt. Now we take V3. Switch on. Yeah, it's here. It's 1 and then half dash. Half dash here, 0.5 multiply 0.1. So half dash is 0.05 plus 1. Plus 1. So the answer is 1.05. 1.05 volt. Switch off. Now that are the readings. R1 4 ohms, R2 5, R3 10, V1 0.32, V2 0.5, V3 1.05. Now the reading of milliammeter. This is the reading of milliammeter. Switch on and take the reading. 5 dashes and half. 5.5 dashes. And each one dash here in the ammeter is 0.02. So multiply 0.02. So the current is 0.11. So the reading is 0.11 ampere. So this is the reading of ammeter. 5 dashes and each one dash is 0.02. Okay? Yeah. Switch off. And now what we do, we need to calculate this. R equals V over I. This is V and this is I. This is V and this is I. So we calculated R equals V, it is 3 volt divided by 0.11. It's a 27.3 ohms. So this is the resistance by calculation. Now, calculate and analyze. Calculate the equivalent resistance RT. Now they are connected in series.
So R total equals R1 plus R2 plus R3. So it's 4 plus 5 plus 10. 4 plus 5, 9 plus 10, 19 ohms. So R total by calculation is 19 ohm. But from the reading, it was 27.3 ohms. Now, compare your calculated value of R in the table to the equivalent resistance R. The calculated value is more than the equivalent resistance. By how much? We do divide. So 27.3 divided by 19. Divided by 19. So the answer is 1.4. So the value, this 27.3, but R total is 19, so it's 1.4 more than. How does the voltage drop across each resistance relate to the voltage drop across the interval? Now, for the voltage here, it is 3. If we add this one, 0.32 plus 0.5 plus 1.05, the answer is 1.87. So, how does the voltage drop across each resistance? It will be less than the voltage drop across the entire circuit. So it will be less than. By how much? We can say 3 divided by 1.87, so 1.6 times. So the voltage drop across each resistance is less than the voltage drop across the interval by 1.6 times. Again, the sources of error in this experiment. Now, it's connected, so and each wire has own resistance. So the resistance not only R1, R2, R3, but also the resistance of the connecting wires. Also the losing connecting in wires. So maybe we have loss of connection in the wires. The reading of voltmeters, parallax error. So that are sources of error. Now what? Now for the conclusion. Why we doing that experiment? To verify that R total equals R1 plus R2 plus R3 if the resistors are connected in series. In this experiment we found that R total equals 27.3, but R1 plus R2 plus R3 was 19. Big difference because what? Because many wires we used them. Each wire has own resistance, so this is a source of error in that experiment. But approximately R total equals R1 plus R2 plus R3. It means we verify that the equivalent resistance equals the sum of resistors when they are connected in series. Thank you.